Very well. Okay, on today's show, trig functions. Everything we need to remember about trig functions, everything we need to see about trig functions. This is the lesson that's going to start with a quiz. The quiz is not part of the video lesson, obviously, but you should be ready for quiz, which is super. And then we'll dive into a talk about trig functions. So, things you need to know about trig functions. You need to know what they look like. So we'll look at the 6 trig functions. 2 of them are very, very familiar to us. We have the cosine curve, a very familiar curve to us. The cosine curve is a periodic curve, which means every 2 pi it does the same thing. In fact, all the trig functions are periodic, which means that every so often you get the same picture. This curve maxes out at 1 and mins out at -1. It's a very familiar picture to us. The sine picture is also familiar to us. And again, it is periodic. Every 2 pi, you get the same picture. Again, it maxes out at 1 and mins out at -1. You would think that the sine graph and the cosine graph are just horizontal translations one of the other, and you would be right. You would be absolutely right. The sine graph and the cosine graph are translations one of the other. The tangent graph, a familiar graph from, I should have done the infinite cloner thing. Tangent graph, a familiar graph from our work last year. Tangent comes directly from sine and cosine because tangent is sine over cosine. Sine x over cosine x is tan x. And so what does that mean? That means everywhere the sine graph is 0, the tangent graph will be 0, which means the tangent graph is 0 every pi. 0, pi, 2 pi, and so on. Everywhere the cosine graph is 0, the tangent graph has an asymptote, a vertical asymptote, because everywhere cosine is 0, tangent is undefined. And so you remember that the graph looks something like this, and it repeats itself with a period of pi. Every pi, you get the exact same picture. There it is. Likewise, the cotan graph. The cotan graph, that's cosine x over sine x. So everywhere the sine graph is 0, the cotan graph has an asymptote. That happens every pi. And everywhere the cosine graph is 0, the cotan graph is 0. And so you get a slightly different picture. It's a translation and reflection of the tan graph. It is a translation and reflection. All right, excellent. At the bottom of the page, let's talk about secant and its close friend cosecant. Secant and cosecant play off of cosine and sine, so let's give you the cosine graph so that we know what we're doing here. That's the cosine graph. The secant graph, secant x is 1 over cosine x, which means everywhere the cosine graph is 1, the secant graph is also 1. And everywhere the cosine graph is -1, the secant graph is also -1. And everywhere the cosine graph is 0, the secant graph will be undefined. Undefined, undefined, undefined. And so what you end up with, oh, one more thing, ha 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 ha. Cosine values have absolute values between 0 and 1. They are what we commonly call fractions. So when you take the reciprocal of some fraction that's less than 1, you get some number that's bigger than 1. And so the secant graph lives outside of the -1 to 1 window. It lives from 1 to infinity and from -infinity to -1. The secant graph looks like that. There's your secant graph. And cosecant looks much the same because cosecant x is 1 over sine x. And so you get asymptotes every pi. And you get that bottoms out at 1. That tops out at -1. And again, we're periodic, so every 2 pi, we get the exact same picture. Okay, those are things with which you need to be familiar. You also need to remember that all of trigonometry is done in radians, so we're only going to use intervals like 0 to 2 pi or -2 pi to 2 pi. Those are the only things we're going to use. And you need to know things like evenness and oddness. For example, the sine function, oh, give me magic pen. Can I get magic pen? Can I get magic pen? Can I get magic pen? Let's get magic pen. The sine graph is what we call an odd function. It has origin symmetry. F of -x is the negative of f of x. Similarly, the cosine graph is an even function. It has y-axis symmetry. F of -x is the same as f of x. So, folks at home, is cosecant even or odd? That's right. It is odd because it has origin symmetry. If you take the reciprocal of an odd function, you get an odd function. How about secant? Is secant an odd function or an even function? That's right, it's an even function because it has y-axis symmetry. Okay, so that's what you've got to know about the graphs of trig functions. You also have to know how to connect the graph of a trig function to the equation of a trig function. And the equation of a trig function generally looks like so. And even though we give some fancy schmancy vocabulary, it's the same stuff we've always done with transformations of functions. This number in front, the absolute value of a, is traditionally called the amplitude of a sine or a cosine function. Absolute value of a is the amplitude because amplitude is a distance and that's always positive. So even though a itself may be negative, the amplitude is always positive. But what is A? A is a vertical dilation. It's just a vertical stretch. So the amplitude, we talk about that being the height of a sine function, but really it's just a vertical stretch. So what happens here? B. That's your period. Your period, the length of horizontal distance required to repeat the cycle. C. C is the horizontal shift of the sine graph. If C is positive, we shift to the right. If C is negative, we shift to the left. And D is the vertical shift. If D is positive, we go up. If D is negative, we go down. And so if I'm looking at the graph of y equals 4 sine of 2x plus pi minus 2, well, then I know that the amplitude of that graph is 4. That's not hard. And I know that the vertical shift is -2. So I already know when I'm going to graph that the midline will happen at -2. The midline is going to happen at -2. And the amplitude is 4, so this is going up to 2 and down to -6. I know that the graph is trapped between those two values. And I know it's going to look like a sine graph, but what will be its period and how will it be shifted? Well, to do that, we've got to rewrite this as 2 times x plus pi over 2. The pi over 2 becomes the shift to the left. And the 2 tells me, is a nice little formula that tells me that 2 pi divided by 2 is your period. 2 pi is always in that formula. This 2 ends up on the bottom. Some people refer to 2 as the frequency. If they talk about frequency, that's the number they're talking about. Frequency is the number of cycles you see in a 2 pi window. So pi is the period of my function. So what do I know? I know that at -pi over 2, I start, I hate the term, start a sine curve. So let's see, here's -pi over 2. I'm going to start a sine curve. And I know that that sine curve has to end after a period of pi. So at +pi over 2, I end the cycle. The cycle hits 0 in the middle, and then it maxes out and mins out, and we get that picture. But we get that picture every pi. So if I go ahead to 3 pi over 2, I know that I'm 0 in the middle, 0 at the end, max out, min out, fight, fight, fight. And so I can just continue to do that forever and ever and ever. So you ought to know the pieces of a trig function. That's part of what we do. All right, one more thing. Gotta talk about inverse trig functions. Gotta talk about inverse trig functions because they matter. So if I'm going to talk about the graph of the inverse cosine function, I first have to talk about the graph of the cosine function, and the first thing we should remember from our time together yesterday is that this cosine function, magic pen, this cosine function is not one-to-one. It fails the horizontal line test in 11 billion places. So what does that mean? That means I have to find a way to make that function one-to-one. And the way we do that is we restrict its domain. We restrict its domain to some place where it is one-to-one. If we cut things off at 0 and pi, we restrict the domain in such a way that the function is one-to-one. So the point 0, 1 is on the original graph, and so the point 1, 0 is on the inverse graph. The point pi, -1 is on the original graph, and so the point -1 pi is on the inverse graph. We also have 0 pi over 2, and the graph looks roughly like that. Notice that the cosine function is decreasing from 0 to pi. The inverse cosine function is decreasing from 0 to pi. The inverse sine graph looks similar, comes from a similar pattern. We cut off here at -pi over 2 and pi over 2. That allows us to have a one-to-one function, and so the inverse sine graph looks like that. And again, when we say inverse sine, we mean that y is the angle whose sine is x. Pi over 2 is the inverse sine of 1. Pi over 2 is the angle whose sine is 1. Aren't there many angles? Yes, but we have restricted the domain to allow for the inverse function to exist. And if you're interested, the inverse tan graph, we cut off at negative pi over 2 and pi over 2. When we reflect over y equals x, vertical asymptotes become horizontal ones, and so you end up with this graph running with a range from negative pi over 2 to pi over 2. And of course, the angle whose tangent is 0 is 0. Okay? So those are the big things you have to, excuse me. Those are the big things you have to remember about trigonometry. And tomorrow, more fun will ensue. Thanks, everybody.